Today we're going to talk about enthalpy. More specifically, the most important equation in doing these type of problems, Q equals mc delta T. This is an equation that helps us understand the amount of heat in a system and how that system changes with different energy and time. Let's start by breaking down what each thing means. We'll start with Q. Q is the energy of the system. It's the heat transferred to a system over a certain time. M is the mass of the object that we're talking about. So this could be the mass of water undergoing temperature change, the mass of a cube being heated. The reason we want mass is because of C, which is the specific heat capacity. And this specific heat capacity refers to the element that the object is made out of. For example, an aluminum cube will have a different specific heat capacity than water. And this is because it takes different amounts of energy to change those things by 1 degree. And so the specific heat capacity is the energy needed to change 1 gram 1 degree Celsius. Delta T is the change in temperature that you're looking for, and it's the final temperature minus the initial temperature. This equation helps us determine the amount of energy that we would need to change a substance by a certain temperature. So if we started at 0 degrees Celsius and went up, how many joules of energy are we going to need to put in if for every joule it goes up 1 degree Celsius, or for every 2 joules it goes up 1 degree Celsius? That's what this equation tells us. Let's start with an example. This problem asks, how many kilojoules do you need to make the perfect cup of hot chocolate? So, we'll say that our perfect cup of hot chocolate is 300 grams of milk, and that our perfect temperature is 136 degrees. So, we can also find that the specific heat capacity of milk is 3.751 joules per gram degree Celsius, and it's safe to assume that our refrigerator keeps our milk at 38 degrees Celsius, and so this would be our final temperature, and this would be our mass. So we have everything to plug into our equation. Now let's do it. We're looking for Q, since they're asking for kilojoules, which is energy. And then we need the mass of 300 grams, the specific heat capacity of 3.751, and our temperature change, which is our final minus our initial. Now if you look at this equation, you can see that grams cancels and degrees Celsius cancels, giving you joules, which is what we're looking for, since we can convert joules to kilojoules. So, let's do the math. This will all come out to equal 110,250 joules. Now, to change that to kilojoules, we can just divide by 1,000. And that is equal to 110.25 kilojoules. So what this means is that if I had a beautiful cup of hot chocolate and I wanted to make it the perfect temperature of 136 degrees, then I would have to put it in the microwave in such a way that 110 kilojoules of energy would go into the cup of hot chocolate to make it the perfect temperature. And we know this because we know that for every 3.75 joules that go into this cup, it will go up by 1 degree Celsius. And that's if we had 1 gram. Since we have 300 grams, we multiply our weight by the specific heat capacity, since this is per 1 gram, to cancel out grams and get it in how many grams we have. And then we multiply it by the change we want, since this is per 1 degree. And that gives us the energy that we would need to put in to get the perfect hot chocolate, or to find the change in an ice cube dropped into water, or any of the problems you may see going forward.